Hey, let's get started for a new video. Don't hesitate to subscribe to the channel to not miss the next video, like and comment this one. This is the last video about affinities, and we already saw a lot of stuff, and today we will discover a new things. In the previous video we saw the node affinity, the pod affinity, and today we will first discover what is MaxSkew, and after that the pod anti-affinity more in a visual way. We tested it inside the previous video, and we will discover the affinity, but based on the to set it inside the persistent volume. So let's go. The first things, more theoretical part, it's what we named the MaxSkew. So this is how to ensure that you spread well your pods inside the Kubernetes cluster. So remember, during the previous video we scale a lot of pods, and sometimes we use the affinity, and when we used the affinity, sometimes I said that we can't ensure basically how to spread pods inside the cluster. So to spread across the cluster really well the pod, or to try to spread it really well across the cluster, we can use what we name the MaxSkew. It's quite simple. In fact, this is why I won't do a dedicated demo on that. We will do just a demo for the last part of this video on the persistent volume, but we have MaxSkew. MaxSkew take some parameters. Critical parameter into it is MaxSkew, of course. So this is the max. So this is an integer, a max difference, in fact, between the number of pod per topology. So this is a kind difficult at the beginning to understand that. In fact, it's quite easy. I have some schema just after that. After that, you have, of course, the topology key. So when we say we want to determine the number of pods between topology, so it means that, of course, we need to set the topology key, so host name, the zone, or whatever. And when it's unsatisfiable, meaning what the scheduler need to do. Maybe do not schedule if we can't ensure this spread. Schedule anyway. So this is like a bypass, in fact, just trying. It's a little bit like required and preferred. We can say the do not schedule is like the required, and schedule anyway is more like preferred. An example, so this is that just come from the Kubernetes documentation, and don't hesitate to make just a search in your favorite browser, and you need to set inside the pod the topology spread constraint. You can accumulate multiple constraints into it, because there is a S and this is a list. We need to set the MaxSkew, topology key here is just based on the host name. That means that if we have, for example, multiple servers, for example, 3 nodes inside our Kubernetes cluster, and we want to spread well each one deployment inside this cluster. How to do that? We can say, okay, I don't want to have a difference, a number between a number of pods between each node not upper than 1, meaning that I can have 1, 2, 2, or 2, 2, 2, or 1, 1, 2, for example, but I can't have 1, 1, 3, or 4, 1, 1, or 4, 2, 2 if I set the MaxSkew to 1. The max difference need to be under 1. under or equal to 1. Like you can see, we can set a label selector again, so to select the pod on which we want to apply this spread constraint. That means that you can apply it only for the current deployment, only for the pods inside the deployment, but maybe you want to apply it for multiple deployment or based on multiple deployment, and to do that you can use the match label to do that. You have the match label keys as well. Just in a visual way, imagine that we have 3 nodes inside our cluster and we want to spread pod across the cluster. We push, we want 3 replica, we want to have a topology, but based in this case on the region. So meaning that we want to have 3 replica, but we want to try to mitigate the spreading across a region, not on the node, Meaning, if we want to summarize it, we can change the view of that, like I don't remember where it is. No, maybe yes, it's like that. It's like that, in fact, because we are in region, we have pod 3 on the first node, but only on the region EU West, and on the region US East, we have 2 pod. So if we have a skew set to 1, and we have a topology region, it's okay, in fact, because we have only 1 node on EU West, but we have only 2 nodes on US East, and we are based on the region. But if, for example, I scale up my deployment, I want to have 4 replicas inside this deployment, which manages this pod. In fact, this new replica, because I need to have 4, the scheduler will check the skew spreading and say, okay, my MaxSkew is set to 1. That means that I can't add a pod on the US East, because if I do that, I will have 3 pods here, 1 here, and my skew will be equal to 2. So with that, I enforce in fact the pod 4 to go here. So it's really good, in fact, to spread pods inside your across your cluster for sure. So this is why MaxSkew is really interesting, because if you don't set MaxSkew and you want to manage a topology, but you want to ensure that your pods are spread across this specific topology, you need to make something, because by default you are really not sure that the scheduler will schedule pod like with an equal repartition across the cluster. Okay, so this is the first thing. The second thing is the pod anti-affinity. So we already tested it in the previous video. For the pod anti-affinity, we have the required and the preferred scheduling, so that don't change. That doesn't change, and we tested it in the previous video, but we can imagine two use cases, in fact, just to have it in mind. Imagine that we have a cluster with multiple nodes. We have we are on 2 zones, but it's not really important. And for example, I want that my application front end won't be deployed on the backend. So for that, I will use pod anti-affinity, and I say, okay, I don't want, so it's not true logic. It's better to use it, for example, with a database. If you have a leader and followers, we can imagine here the backend is a leader and we have some followers, and for sure we won't have with the pod anti-affinity, we won't have, and we don't want to have the follower at the same place like the leader. So this is where pod anti-affinity can be really really cool, to be sure to not have the same pod on or not between applications. So this is why I use the example about the front end and back end. Here we are cross application, meaning that we have one application here, second application here, but we don't want that the first application will be deployed at the same place of the second application. So this is the pod anti-affinity. We have two deployments, one for front end, the second one is for back end, and we use inside the front end settings, we use a label about backend to say, okay, I don't want, and this is pod anti-affinity, I don't want to be at the same place, so the same topology, in fact, so that can be the node, the zone, or the region, that depends of what do you want to do, and I don't want to be at the same place as our backend. But maybe I want to use pod anti-affinity on myself, on the pod itself, on the deployment, on the same deployment itself. For what? Just for spread across the cluster. But like I already said, with that, you can only manage one topology kind, or one type of topology, meaning that, for example, I push a deployment for my backend, and I can set into my pod anti-affinity a label based on app equal backend. So this is just an example, and for that the first pod will be deployed, for example, on the one node here, but after that, when the scheduler want to set the node name key for the second pod about our backend, it just checks the one and say, okay, there is already a pod here, and so I need to go either on the 2, on the 5 node, or and so on. So I will push the second pod on the 2 node here. And exactly the same thing for the third pod. It's exactly the same calculation, in fact, into it. So it's really cool, but in fact with that, it's an exclusive condition. That means that you can only use it to spread across the cluster, but for only one pod here. So with this case, you can only distribute one pod per node, but not two pod not ensure 2 pod per node, for example. So this is where, in fact, the MaxSkew is really, really useful if you want to mitigate that and to have, for example, here 2 backend on each node, or not exactly, not 2 backend on each node, but more to say, okay, I want to have a difference between my topology, so that depends, the node maybe. I want to have only one difference, one pod of difference between each node, meaning that I can have 2 here, 2 here, and 1 here, or maybe 1 here, 1 here, and 2 there. Okay, so this is what we sum up here. So now we can discover that we can use the node affinity for our persistent volume. Just, in fact, to keep it in your mind, you can have pod affinity, node affinity. So here it's more node affinity, in fact, for persistent volume, but you can use it to ensure that your persistent volume will be at only one place, and for sure the pod which will use this persistent volume need to be at the same place of the persistent volume. So if you just if you pin or if you fix a node for your persistent volume, this is a classical, the pod on it will be for sure at the same place. Let's go for a demo about this use case. What can I do? So I can just maybe what can I do? Okay, so here I have my my persistent volume, in fact, and I can set it like here. So I set a new manifest. So I can say, okay, I'm in demo. I can say PV for persistent volume YAML. I can set here my my pod number. So it K0. I can say I want to fix it on K013 like that. Okay, so K0C13. Yes, K0C13. And if I apply it. PV, normally if I go on key 0C13 inside the server, okay, if I use mnt /data, no, yes, it's not mod, okay, so I can check kubectl get PV, okay, so I can just reduce it like here, kubectl get PV, get PV like that. Okay, I have my PV just right here. It's available in retain mode, and I say okay, this PV can only be mounted on this server. Okay, so now what can I do? I can use it, and to use it, remember that we need to use a PVC, classical PVC. So it's a local storage. In fact, it's not really. This is not really a usual use case, in fact, but it's good to have it in your mind. I can do it like that. Okay, I can say I use exactly the same storage class, so this is a manual to be sure to use the persistent volume. If I apply the persistent volume claim, apply PVC dash F PVC like here. Okay, so if I check PV and PVC, we are okay, and the volume associated to our PVC is good, in fact. So it's a PV affinity. Now I can, for example, deploy a Postgres application to use this PVC. So I can do that. Maybe it's more like here. Okay. And okay, so I can say no. I can say pg.yaml like that. Okay, I will have a Postgres in 16. The user will be admin. The password will be password, and we will have a default database named testdb. Okay, so let's go, and we will use the PVC and mount into our container this PVC to store the data directory for Postgres. Okay, so if I set kubectl apply in my CLI dash f and pg.yml like that. So container creating that will take a few seconds. Okay, dash W just to watch, and after that I can yes, I can expose. It's not. Oh yes, I can expose after that. I can directly apply it. So I just expose the Postgres port with the kubectl get service. We will have the service based on the Postgres deployment, because this is an exposed deployment Postgres. Just to check, and if we check, we have a running container. I can check the endpoint if you want. Okay, we have an endpoint, so it's quite good. And just after that, we can use this CLI, like here. Why 13? I don't know, but maybe more 16. Directly to have a terminal. This is what is pop. Can check on host path normally /mnt data. Maybe yes. So with the sudo, of course, if we check, what do we have? And it's on key 0c13. We have our data files for our Postgres. So this is a lot of things about Postgres. So this is a varlib Postgres, in fact. And I can try to connect into it. To do that, yes, I can run it directly, like that. Okay, my password is maybe password. Yes, it's password. I can create a table, this table here. Okay, and if I check dash /dt, I have my table named xavkey. I could insert data into it, insert into xavkey, it's into xavkey. I can insert into xavkey values 1, for example, like here. Okay, and 2 if you want. Okay, like here. And if I make just a select count star, like classical things from this is xavkey, and we have 2 lines into it. Okay, and data are stored on the key 0c13. So if I go just I can just yes, I can leave this terminal. I can check my pod. If I check my pod, what I have the key 013 here for my pod Postgres, but I haven't set any pod affinity or node affinity inside the deployment. This is only on the persistent volume to ensure that the persistent volume will be forever on this node. So if I just scale to 0, kubectl scale deploy Postgres -- replicas equal to 0. Okay, if I do that, of course, no pod into it. If I scale to 1 again and kubectl get pod, it's quick because there is no choice for the scheduler. The scheduler need to mount this persistent volume. This is due to our Postgres deployment. So here there is no pod affinity or node affinity in this case. It's only the affinity is just enforced by the persistent volume through the persistent volume claim. There is no choice, in fact. It's only on this node, and that can be on another place in the cluster. It's really useful. It's very stateful, in fact. So it's not a really good pattern, but it can be really useful, in fact, if you want to mount a specific pod on a specific volume, or to ensure that your Postgres data will be forever here. When it is used, when you can't use a shared storage, for example, for performance, you need to use what we name the local storage. So local storage is the disk, specific disk where the pod will be, on the node where the pod will be. That ensures that if you have an SSD under the pod, you can use it. And if the pod, like we did, if the pod is just drop and recreate, it will be only recreate on this part. It's not really great. Why? Because if you lose this node, you will lose the volume, this volume, and meaning that it's just drop forever. So this is where the backup is really important, but it's a really good way to mitigate the performance, the high performance for database or for some other tools where you need to store data and where SSD is required. Of course, before to do that, if you can, it's really better to use like a shared storage or an external storage with high performance. It's really better, but it's the performance here is really, really good. You can use ZFS or stuff like that to improve the performance, to ensure that you have a distributed storage or stuff like that. There is a lot of kind of design pattern for this kind of storage, in fact. That's it for today. Thank you for following this video. Don't hesitate to subscribe to this one, like and comment this one, and see you in the next one. Bye bye.